Hello guys, welcome to another video. So now we will go through the next module, next module for Unit 2, which talks about setting up the CAP project. So the next module which we have to cover is discovering the end-to-end use case. So in this module, let us see what it talks about. Let's begin by considering the following scenarios. So in this video, there is a scenario which has been provided to us. Say, for example, there is an organization which is having an export business and they want to manage the risk of their export business. Their business is managed or is run in SAP S/4HANA system, and that is where their business processes run. They have created some in-app extensions to manage risks for their business, but to manage it in a better way or to handle more custom needs of risk management as per their business requirements, there is a need for creating side-to-side extensions also for their SAP S/4HANA business process. And to implement those side-by-side extensions to basically create a separate side-by-side application to manage their risk, SAP BTP will be used, and in SAP BTP, we'll be creating an extension application, which will be a side-by-side extension application for their SAP S/4HANA system. And this external or this side-by-side application on SAP BTP will be used to manage the risks of their export business. So that is the scenario which they are talking about. So this is the scenario on which we'll be working on, and we will be creating this side-by-side extension application in SAP BTP. So this is the preview of the final application, and this is the preview of what we will create as part of this application. So it says this course offers a comprehensive guide to building and deploying a full stack CAP extension on the SAP Business Technology platform. Okay, so building and deploying a full stack CAP extension. That is what we will do on SAP BTP. So what all will be covered? First point is jumpstart a new CAP project. So we will create a new cloud application programming project within SAP Business Application Studio. We'll model the database entities with core data services, design and define database entities. Then we'll expose the backend as an OData service, basically through an OData v4 service. Then we will connect and consume external services. So we will integrate APIs from an SAP S/4HANA cloud system in our CAP application. So we know that in our scenario, the business is managed in a SAP S/4HANA cloud system. And we will make use of an API which is exposed from the SAP S/4HANA cloud system, and we will consume that API in our CAP application. Event handling in CAP, this is also something which we will achieve or we will learn. Add custom business logic using JavaScript. Restrict service with role definitions. We will define roles and restrict the access to our application only to the users who have the required roles to access the application. We'll prepare for deployment. We'll add required configuration files to prepare the application for deployment. And manual deployment into SAP BTP Cloud Foundry runtime. Then we will manually deploy our CAP application to SAP BTP Cloud Foundry runtime. So ready application for continuous integration and delivery. So as a last step, we will also ready our application for CI/CD. So all of these steps or all of these 9 points we will achieve in our side-by-side extensible application. So the front end will be built with SAP Fiori elements, which consists of 2 parts: a list page, which will list all the risks, and an object page, which will be a detailed page for displaying further information for each risk entry. So we will create a SAP Fiori elements application, UI application. Users of this application will then be able to create, edit, and delete risks from the list page. So these are the actions which will be available to the users to create, edit, and delete the risks. Each risk has the properties of impact and priority based on each risk's potential. So each risk will have a property called impact, which will say that, okay, how much impact this risk has and what is the priority of this risk. The risk manager can assign mitigations to the identified risks. So in our risk management application, which we will implement in SAP BTP in CAP. A user, say for example, risk manager, that risk manager user can assign mitigations to those identified risks. Both risks and mitigations are stored in the extension's own database. So whatever data we will make use of, like for what risk, what are the risks and what are the corresponding mitigations, that data will be stored exclusively in extension's own database. Like it won't get stored in the SAP S/4HANA cloud system. The database will also be stored in the extension's own database. Details like the name of the individual business partner that is authorized to make decisions will be retrieved from the SAP S/4HANA cloud system. So the business partner details, like the user who is authorized to make the decisions, those business partner details will be retrieved from the SAP S/4HANA cloud system. And this retrieval will be done by making use of the API, which is exposed from the SAP S/4HANA cloud system. So it relates to this point: connect and consume external services, integrate APIs from an SAP S/4HANA cloud system. So we will integrate the API to get the business partner related details. To view and edit a single risk, the user can select an item. This opens the object page as shown in the following figure. So this is an overview or the detail of the end-to-end use case and what application we will be building further going in this tutorial. So what next? The next step is to guide through an end-to-end development process and development or to and deployment and development to automated deployment. Okay. So let's go to the next lesson. Now, this is an exercise-based lesson where we will be going through and executing all these steps one by one, and we will create CAP-based service. So business example, we know that what is our business example. We will now look at how to create a CAP-based service. So the exercise options, either you can do in a live environment or you can do on it in platform simulation. Live environment means using the following instructions provided, you can perform the steps in SAP BTP free tier account. That is the live environment. You can practice this. There is a platform simulation also where you can follow the step-by-step instructions within the simulation by choosing the start exercise button. So the recommended way is to perform these exercises in the live environment, recommended perform steps in the live environment. Now, prerequisites before proceeding with the exercise, make sure you successfully created a BTP free tier account and created and opened your dev space for full stack cloud applications in the SAP Business Application Studio. So these are the two prerequisites we have to make sure are completed. In case you haven't created a dev space, follow the simulation below to see the steps involved. So this is how the simulation works here. This will open this new window where the simulation of the exercise is available. So step by step, it will guide you to learn more about how to create a CAP-based service. Follow this interactive tutorial. This is an interactive tutorial. So now in the following steps, you create and initialize the project. So it will tell you that, okay, what all you have to do. So again, this interactive tutorial also assumes that you already have an SAP BTP account and you have also created a dev space in your business application studio. So once these two steps are like you already know about them, then it will tell you that, okay, you have to click on terminal, new terminal, and then it will tell you what is the next step. You can now see that a new terminal has been opened in the lower right part of the business application studio screen. Then it will tell what you have to type here in the terminal field, enter MKDIR projects risk management and press enter. So we can do that. MKDIR slash risk hyphen. Yeah. So like this step by step, it will tell you and it will guide you through the entire tutorial. So this is the platform simulation way of going through the exercise. But there is another way, which is a better way and the recommended way to performing it on your own in the live environment. So this is what we will be going to do. We will create an SAP BTP account, and these steps will perform step by step in our SAP BTP account. So first of all, as a prerequisite, we will create an SAP BTP account. So let us do that. To create the account or log into the SAP BTP cockpit, you need to go to this URL account.hana.ondemand.com, and then you can just sign in. And we already have a subscription for SAP Business Application Studio. So I think this subscription gets created by default when you create an SAP BTP account. So you go to your Business Application Studio. This is the development environment where we will do all the coding for our CAP application. So SAP Business Application Studio. So first thing is we have to create a dev space. Okay. Now, when we are creating a dev space, what kind of dev space we want to create? So you can say that a dev space is kind of a virtual machine where all these extensions get installed and your development environment gets created for your user to perform your development activities. So that is what a dev space is. So we have to create a dev space for full stack cloud applications. Okay. So we'll go here, full stack application using, we will create dev space for this type of application, full stack cloud application. So when we select this option, all these like development extensions will get installed in our dev space so that we can make use of them to create our full stack cloud application. So build business services and business applications and extend SAP S/4HANA using cloud application programming model. So you have to create dev space for full stack cloud application. So create dev space. Oh, we have to give a name. So this is just we can have given a name for our dev space and create dev space. So our dev space will be created and it will be in started status, and then we can make use of the dev space. Basically, we can write code in our business application studio. So once these two steps are completed, then we will go through these steps one by one. So our dev space is up and running. We will enter into the dev space and it will launch the SAP Business Application Studio. All right. Now what we have to do in the Business Application Studio, terminal, new terminal. Okay. Terminal, new terminal. And a new terminal opens in the lower right part. Okay, fine. And then this is the code snippet we will execute in the terminal. So here what we are doing is we create this directory called risk management in the projects folder of our workspace, and we go into our risk management directory, which is basically the application, and then we clone the application from this particular GitHub repository. So this is what these statements are doing. So there is an application like a sample base code which is available for us to use, which is provided by SAP. So the template from GitHub has been cloned successfully. Next, open it in the Project Explorer. So files and folders, USR. projects and risk management. So this is the application which we have cloned. So this is a sample application which is already provided by SAP. And we have cloned it in our risk management folder into our business application studio. Now we'll again open the terminal for our application. So let us do that. Terminal, new terminal. Now here we'll run this command npm CI. What will this command do? So this command installs all dependencies of your project which are listed in package.json and package log.json file into a new folder called node modules. All right. So this is the project structure. Here we have package.json file and we also have a package-log.json file. So what all dependencies are mentioned in this package and package-log.json file, those dependencies will get installed when we run this command npm-ci. And this will create a folder here, node modules, and all the dependencies would be available inside this node modules folder. All right. Now, next is we will run this command in the terminal cds watch. What this command will do? The cap server serves all the cap sources from your project. So all the sources will be served from our project. Sources as in say for example the UI part or the data model part or whatever constitutes our application, it will be served from our project. It also watches, so cap server watches all the files in your projects and conveniently restarts the server whenever you save a file. So whenever we are making code changes in our project and we save a file, the cap server keeps watching for the changes in our project and it restarts the server whenever we save a file. So changes you have made will immediately be served without you having to do anything. So that is the beauty of this CDS watch command. So all the dependencies have been installed. Now we will run this command cds watch. So now the cap server has started and it has started serving the content from our project. And we can see that a service is listening on port 4004. All right. So what this command will now, if we make any code change in our project, in our application, we save it, the CDS server will keep watching for any changes and it will automatically restart our application. CDS watch tells you that there is no model yet that it can serve. So currently it says that there is no model available. Okay. Where does it say that? Okay, just maybe some mock data it is serving. So first of all, what we will do, we will add a data model to the project, create a data model using the CDS format in CAP. So because we have to create a data model, based on the data model only, we'll create the service which will be exposed as an OData service and consumed in our SAP Fiori Elements application. So first step is to create data model for the project. So now to create the data model, we'll go to the DB folder. All right, we go to the DB folder. This is where we will create the data model. So new file, we'll create a file called schema.cds, right? Inside the DB folder, new file, schema.cds. Now, this is where the data model will be defined, the CDS data model for our application. So we'll just put this piece of code in this file. All right. So this is how we are defining the data model for our risk management application. So first of all, you are using the namespace risk management. Okay, a namespace is optional. It is helpful to use short, unique names without bloating the code with fully qualified names. Essentially, namespaces are just prefixes that are applied to all relevant names in a file automatically. So this is the namespace. It gets prefixed to all the relevant names in a file automatically. It is basically, you can say, a shortened name or identifier for your application. It is helpful to use a short, unique name. All right. So we are using namespace here. Then the code creates two entities in the namespace risk management. So this is the namespace for our application. Risk management is the namespace. We have two entities. One is risk and the other entity is mitigations, right? Risks and mitigations. Now, each of them has a key called ID and several other properties. So it has title, owner, priority, description, mitigation, impact, criticality, and all. It has ID. It will have ID also. We'll see where the ID is coming from. All right. And the other entity is mitigation. Okay. Risk has a mitigation and therefore the property miti has an association to exactly one mitigation. So every risk will have a corresponding mitigation for that risk, right? So that that risk can be avoided or that risk can be mitigated. So the risk entity has a property called miti, which basically points to the mitigations entity. So it has an association to the mitigations entity here. A mitigation in turn can be used for many risks. So it has a too many association. So one risk, say for example, this one risk will have one mitigation associated with it. But this mitigation, it can be applicable for multiple risks, right? So it also has an association to risks, but it is an association to many risks, right? So this is the association here, these two associations. At this point, you can ignore the commented property BP as well as the other commented lines further down in the file. You will use the commented lines at a later stage of the project. So for now, we ignore this business partner association for now. This is another entity, priority, which basically it provides a list of values, okay, enum values for the priority property where this entity will be used, all right? Here, association to priority. So it basically provides the values which can be assigned to the priority. Now take a note how CDS watch reacts to dropping the file. It now tells you that it has a model, but there are no service definitions yet. So once you have created this file, CDS watch will identify this change that, okay, we have a data model available, but at this point of time, we don't have a service exposing this particular data model. So that also we will create. Okay. Now add a service definition to the project. In this part, you will create a new service with two entities. Both are projections of the data models that you created in the previous step. So this is the data model with two entities which you want to expose, risks and mitigations entity. Now we will create the service entity. Sorry, we will create the service to expose these entities. All right. A service provides an interface to the application. It enables other applications and users outside of the application to interact with it. In this case, the service lets us interact with risks and mitigations entities. That is what the service will do. Thus, the data within the application. For this, create a file called risk-service.cds in the SRV folder. So we go to the SRV folder and we create this new file. Okay. And this is the content of this file which is provided here. Now, here you can see that the risk service, it exposes the risks and the mitigations entities from the data model. So using risk management is the namespace which we have provided to our data model. So it says using risk management as RM from DB schema. And this is the name of the service, risk service. And these are the entities. So this is the entity name in the service. And this entity name, this is a projection on the risks entity on our database model. This is what it means. Again, entity mitigations, this is the entity name in the service, and it is a projection on the mitigations entity on the data model. Now we have to provide mock data. Okay. In CAP, there is a way to provide mock data for the created entities. The data is stored in a local database called SQLite that CAP invokes behind the scenes. CAP makes it easy to add such test data to a service. So for now, like our application is not connected to a persistent database, so we will provide some mock data in our DB module, which can be exposed using our service. So when we have to provide such mock data, we need to provide a comma separated file, CSV file, that contains entities elements as column headers. Okay. Now we have to go to the DB folder and then to the data folder. So it already has this data folder and it already has the data. Okay. So this data is already provided from the GitHub clone, from the GitHub sample, which we have cloned. So you can see that these are the properties of the risk entity ID created by title, owner, prior code, description, MITI ID impact, and these are the corresponding values. So this is how the values are separated from each other. And this is how the mock data has been provided. So in a table format, the header and one line of the file content look like this. So you can just visualize that the header and the first line will look like this in a table format. So ID, value of ID created at, and then the corresponding value of created at, which is this, then created by, like this. This is how we provide mock data. Now we will investigate the files, the data files which we have created in the data folder, and we will see how the content has been provided there. So the files have the name of the namespace of the entities in the data model. So if you see the name of these files, they start with risk management. Risk management is the namespace which we have provided, right, for in our data model. So the names of these data files, they start with risk management and hyphen, and then these are the entity names. So mitigations, priority, risks, okay, followed by a hyphen and the name of the entity, for example, risks. So when adhering to this naming convention, CAP recognizes the file as data for the data model and automatically adds it to the built-in SQLite database. So CAP automatically recognizes that, okay, this data file is for the mitigations entity, this data file is for priority entity, or this data file is for risks entity. And these entities are provided here in our schema.cds file. So based on the naming convention, CAP will automatically recognize the entity and the corresponding data files. And then what it does is that it automatically adds it to the built-in SQLite database. So this built-in SQLite database is used to save the mock data for local testing. Now, looking at the contents of the risk management risks.csv, the first line contains all the properties from your risks entity, while the other ones are straightforward. Consider the MITI underscore ID property in your, okay. So we go to this file and we see that there is this particular property called MITI underscore ID, right? In your entity, you only have a MITI property. So where does this come from? If we go to the entity in our schema.cds, we see that there is a MITI property, but there is no MITI underscore ID property. So where is this property coming from? So MITI is an association to mitigations. So if we see here, this MITI, it is an association to the mitigations property, mitigations entity. So this is the association name, you can say. As mitigations could have several key properties, the association on the database needs to point to all these. Now, this association needs to point to the key properties of the mitigation entity. All right. Therefore, CAP creates a property association property underscore associated entity key for each key, right? So if there are more than one number of keys, say for example in the mitigations entity there are more than one number of keys, then for each key it will create a property in the risks entity which will be like miti hyphen key one, miti hyphen key two, miti hyphen key three, like that. In this case, our mitigations entity has only one key property, which is ID. So it creates this MITI hyphen ID or MITI underscore ID property in our risks entity. So that is what the CAP framework does. One thing to mention here is that how is this ID coming here, this ID property coming here in the mitigations entity data, and how is this ID property coming here in the risks entity data. So if we go to the schema.cds file, we see that so we are using these aspects here: managed aspect, CUID aspect, user aspect, and this sap.common.code list. So if we see this particular aspect called CUID, we can see that this particular aspect provides the key ID. All right. So we can see here we are using this CUID aspect here. So it automatically provides the key field ID in our entity risks. Similarly, again, this CUID, it again provides the key ID in our mitigations entity. Again, if we see this managed aspect, what this will do is this will provide these properties: created by, modified by. These properties will automatically be added into our risks entity. Again, if we see here also, we have mentioned here that we are using the managed aspect. So this will automatically provide the created by, modified at, and modified by properties. These properties will automatically be added to the mitigations entity. So that is why these aspects are very useful. And here we mentioned that what all aspects we are using in our schema.cds file. So that is where you can see that in our mitigations data for this mitigations entity, we can see created by and created at properties being used, because these properties are available in our entities because we are making use of these aspects managed. And this CUID aspect, this makes available the key, the ID field as a key in our entity. Now, again, as always, CDS Watch has noticed that there are files containing the mock data. So CDS Watch will always keep on running. So if your CDS Watch is not running, you can just go to the terminal, go to new terminal, and you can run the command CDS Watch. Okay, so there are other fields like has draft entity were added because you added the at OData draft enabled annotation in the service definition. You have now got a full-blown OData service which complies to the OData standard and supports the respective queries without having to code anything but the data model and exposing the service itself. So what we have achieved till now is that we have created our data model, the CDS data model. Okay, we have created our CDS data model here in schema.cds file. We have provided mock data using these .csv files, and this data model we are making use in our service folder. So in our service folder, we have created a risk-service.cds file, so which basically exposes the database entities as an OData service. So the name of the OData service is risk service. This file does that. It creates an OData service for us. The name of the service is risk service, and it uses risk management. This is the namespace which we have provided in our DB schema file, and it exposes the risks entity and the mitigations entity. These annotations with OData draft enabled and with OData draft enabled for these two entities in the service, we will understand in detail about these two in the next sections. So if we just go through, if we just run the application and open this localhost URL, we can see that the risk entity, mitigation entity, and this priority entity is also there. We can just have a look at the metadata of our OData service. So we can see that these are the entity sets which have been exposed by our OData service. Here we can see the values which we have provided in the mock data in the CSV files. So for our risks entity, these are the values which we have provided. So we can just have a look at them here. In the mitigations also, we can just have a look at those values here. So this is what has been covered in this section of this particular unit. So what we have done here is we have created a CAP-based service. We created a database model, CDS model. Then using the entities in the CDS model, we created a service model, which basically exposes the database entities as an OData v4 service. Just a reference they have mentioned here about these annotations, risks with at odata.draft enabled and mitigations with at odata.draft enabled. So what these annotations do is that they enable edit sessions with draft states. So draft based editing they enable. So what happens basically is that we will see in the next sections when we create a Fiori application on top of this OData service. For these two entities, there will be out of the box functionality provided by SAP Fiori. We can just add some data for our risk entity, and we can just save it as draft without like submitting it to the database, and that draft can be edited at a later point of time also. So that is the use of this particular annotation. We will see it in action in the upcoming videos. In the next section we will go through we have to go through the quiz. Okay, so let us go through the quiz as well for this particular unit which talks about setting up the CAP project. So let us see what are the quiz questions provided here. So first of all, it says, which of the following does OData use to address and access data feed resources? So we know that OData service uses URI to address and access data feed resources. In data models, are namespaces optional or mandatory? So namespaces are optional, they are not mandatory, but they provide a convenience. Which of the following supports non-hierarchical data? So non-hierarchical data is supported by YAML files. Now JSON is based on which programming language? JSON is based on, say, JavaScript programming language, but it's not necessarily to be used only in the JavaScript programming language. Which of the following statements are correct? There are two correct answers. Each JSON file is a valid YAML file, so this we know for sure. Then JSON's foremost design goal is support for serializing arbitrary native data structures. No. YAML's foremost design goal is supporting for serializing arbitrary native data structures. So we have gone through these points in our previous sections. What is OData? Choose the correct answer. It is a standard to share data under a Creative Commons license, a standard to create user interface, a standard to access data through RESTful APIs. So this is what OData is. It is an open standard provided to access data through RESTful APIs. Which command do you use to install dependencies in your project? So we know npm command is used to install dependencies in our project. What are the two structures JSON is built on? So we know that it is built on collections of value pairs, no, collections of name value pairs and ordered list of values. Which document types are associated with an OData service? So one is the service document and other one is the service metadata document. What is the difference between entities and types? Entities represent data, types describe properties. Yes, this is correct. So these are the answers to these questions. If you go through the video of this section, basically explaining JSON and YAML, so most of these questions are coming from that part and from the introducing the OData protocol section. So let us submit it. So all the answers are correct. If you have to go through like in detail, you can just revisit these sections and the answers are just directly mentioned in these sections. So with this, we have completed the second unit, which talks about setting up the CAP project in this video. In the next video, we'll go through the next unit, which talks about serving user interfaces in CAP. So thank you for watching the video, and we'll continue this series in the next video. Thank you.